Hi everyone, I am Geeta, working as Assistant Professor, Department of Mathematics, K.S.Rangasamy College of Technology, Tirchangodu. Today my subject is Statistical Methods. In this method we have 5 modules. One of the modules is Correlation and Regression. Relationship between X and Y. Correlation is there is a relationship between two variables. Regression, how well a certain independent variable predict dependent variables. Correlation is not equal to causation. Correlation is two variables are said to be correlated if the change in one variable result in a corresponding change in the other variable. Correlation first developed by Sir Francis Galton 1822 to 1911 and then reformulated by Carl Pearson 1857 to 1936. The correlation is a statistical tool which satisfies a relationship between two variables. Correlation analysis involves various methods and techniques used for studying and measuring the extent of the relationship between the two variables. The degrees of association between two or more variables is termed as correlation. Definition of correlation. The correlation is the measure of the extent, the direction of the relationship between two variables in a bivariate distribution. For an example, height and weight of children. If the children grown height, automatically the weight will be increased. So, children height is indicated by X means height is indicated by X means weight is indicated by Y. X will increase means automatically Y is also increased. For another example, an increases in the price of the commodity by a decreasing in the quality demand. Next, types of correlation. There are 3 types of correlations. The first one is positive and negative correlation. Second thing is simple, partial and multiple correlation. Third one is linear and non-linear correlation. Next, method of studying correlation. There are 2 types of method of studying correlation. One is graphical method, the another one is algebraic method. In graphical method, we using scatter diagram. In algebraic method, we using Carl Pearson coefficient of correlation. Next, we discussed about Carl Pearson coefficient of correlation. The correlation between two random variables x, y is denoted by R of x, y is defined as the formula R of x, y is covariance of x, y divided by sigma x into sigma y. Where here covariance of x, y is nothing but summation x by n minus x bar y bar. X bar is nothing but mean of x, y bar is nothing but mean of y. Next, sigma x standard deviation, the formula is nothing but square root of summation x squared by n minus summation x bar square. Sigma y is root of summation y squared by n minus y bar square. X and y are two random variables. For an example, find the coefficient of correlation from the following heights of father x and the son y. Father's heights is considered as x, corresponding son heights are considered as y. X values are given by 65, 66, 67 etc. and y values are given by 67, 68, 65 etc. First to calculate what is x, y, xy, x squared, y squared terms. So, x, y, x values are 65, 66, 67, y values corresponding multiplication and squaring these terms we get this table. X bar is nothing but mean of x. Mean of x formula is summation x by n. Adding all the x values and divided by n here, n as 8 terms are given. So, divided by 8 we get 68. Y bar is nothing but summation y by n. Y bar is mean of y by n. Adding all the y values we get 552, dividing by 8 we get 69. Similarly, sigma x formula is root of sigma x standard deviation. Standard deviation formula is nothing but root of summation x squared by n minus x bar square. Substituting x bar squared summation x squared value and x bar square value here, we get the result as 2.121. Next sigma y. Sigma y is square root of 1 by n summation y square minus y bar square. Y bar is nothing but mean of y. Mean of y. Substituting all this value in this formula, we get sigma y is 2.345. Covariance of x comma y formula is summation x y by n minus x bar y bar. Summation x y by n, summation x y already we calculating, adding all those value we get 37560 divided by 8 minus x bar and y bar, we get covariance of x comma y formula value is 3. Correlation coefficient of x and y is given by R of x comma y is covariance of x comma y divided by sigma x into sigma y. Covariance of x comma y is 3. Sigma x already we calculated 2.121. Sigma y is already we calculated 2.345. Substituting here, we get the solution as 0.6032. Next, we discussed about regression. The term regression literally means stepping back outside the average, stepping back towards the average. It was first used by British biometrician Sir Francis Galton, 1822 to 1911. Regression analysis is a mathematical measure of the average relationship between two or more variables in terms of the original units of the data. There are two types of regression equations are there. One is x on y, the another one is y on x. The first thing is equation of line of regression of x on y. In x on y, the formula is x minus x bar equal to bxy into y minus y bar. X bar is nothing but mean of x, y bar is nothing but mean of y. Bxy formula is summation x minus x bar into y minus y bar divided by summation y minus y bar whole square. In that similar manner, equation of line of regression of y on x. Y on x equation is y minus y bar equal to byx into x minus x bar. Byx formula is summation x minus x bar into y minus y bar divided by summation x minus x bar whole square. Next, for an example, obtain the equation of the lines of regression from the following data. X values corresponding y value was given. First, to calculate x bar and then y bar. X bar is mean of x, y bar is mean of y. Adding all the x value and divided by the number of terms, we get x bar. Adding all the value divided by number of terms, we get y bar. And then we calculate x minus x bar, y minus y bar, x minus x bar whole square, y minus y bar whole square, x minus x bar into y minus y bar. Adding all the corresponding results. X bar is summation x by n, we get the value as 4. Y bar is summation y by n, we get the result as 11. Similarly, bxy formula substituting here, summation x minus x bar, y minus y bar divided by summation y minus y bar whole square. Substituting all those values here, we get the result as 0.9285. Byx is summation x minus x bar, y minus y bar divided by summation x minus x bar whole square. Here we are getting the result as 0.9285. Regression of x and y is x minus x bar equal to bxy into y minus y bar. X minus x bar value is 4, that is equal to bxy is 0.9285, y minus y bar is 11. Substituting here, we get the regression equation as x equal to 0.9285y minus 6.2135. This is one of the regression equation. The second line is equation of line of regression on y on x. Y on x is y minus y bar equal to byx into x minus x bar. Y minus y bar is 11 equal to byx value and then x minus x bar is 4. Substituting here, we get this equation as y equal to 0.9285x plus 7.286. For another example, the regression equation of x on y and y on x are respectively two equations are given. Find the mean value of x and y. In previous problem, x and y data are given, we may calculating the regression equation. But in this problem, regression equations are given, we have to calculate x and y, mean of x and y value. Since both the regression equation passes through x bar and y bar. So, x and y in this place we have replaced by x bar and y bar, we get first and second equation. Solving these two equations in any method, we find the x bar value was 6 and y bar value was 8. Thank you.